Welcome to MEI Modelling with Algorithms. We're on the topic of Graphs and Networks 2, Minimum Spanning Trees and Shortest Paths, and this is video 2.2, Minimum Spanning Trees, Prim's Algorithm on a Table. Now it's worth saying at this point that Prim's algorithm is an example of what's called a greedy algorithm, in that it just goes immediately for what seems like the best option at the time. And actually, as we saw in the previous video, that strategy, certainly when it comes to minimum spanning trees, seems to actually work and always give you the optimal solution. Now, as I say, we've seen that in the previous video on a graph, but what if, as we know that graphs and networks can be represented in the form of a matrix as well, so how could we tackle a problem when it's presented in that form? After all, that'll be the form which is most useful for computers. Obviously, we could just draw the graph and then go from there, but actually there's a much more efficient way of doing it, just sticking to the table itself, and that's what we're going to see. So this is how the algorithm is written when we're doing it on a table. It is actually exactly the same algorithm as in the previous video. It's just because it's referring to the table, it might look a little bit different. Just spend a moment or two, pause your video and read through the steps firstly. So looking at the first step, it says choose a starting node. Now sometimes it may be that you're told which node to start with, and if you are, then you must start with that node. If you're given the choice, then you can choose any. For the purposes of this video, we'll always choose node A, and we'll just keep consistent with that. So that means that we need to number column A with a 1, and then delete the row corresponding to node A. So let's do that. Then step 2, we look down all the numbered columns. Well, there's only one numbered column at the minute, and find the smallest value that's there and circle it. And then what we do is we take that node, which is we chose node C, and we label that as the next column. So we'll put a number 2 above the C, and then we'll delete the row for C like this. Now, you may be wondering what the purpose is of deleting these rows. If you think about it, the thing we need to make sure we don't do with prims is accidentally create a cycle. Now, by deleting a row once that node has been added, it means that we're never going to choose to go back to that node, so we're never going to complete any cycles. Right, so we need to repeat steps 2 and 3 now until all the rows are used up. So we've got our 2 columns now. We need to look down both of those, and it is important to look down both of those to find the next smallest number, and that's this 2 there. So we'll now circle that one. That one, of course, is for node B, so we've now added node B to our tree. So we'll label B at the top with a 3, and we'll delete the rest of row B. So now we have 3 nodes in our tree. We've got 3 columns to look down, again looking down for the smallest number that's not yet been deleted. That's this 3 here, so we'll circle that one, which is in the row for node E. So now node E is added to our tree. And finally then, the only row that's left is the one for node D. So looking at all of these numbers, we see that the smallest one is the 1. And so we add node D, and then that's all the rows used up, and so we're finished. Of course, just like with the previous video, what we really need to do now is firstly list the arcs in the order that they were added, along with their weights and the total, like that. And we can use these orderings that we labeled at the top to work out what order those arcs were added in. So here's another example. This time I'd like you to pause the video and try this yourself. It may take a little bit of time to copy the table out. If you want to take a screenshot and print it, do that way you can. But have a go at that, and then in a few moments' time we'll reveal the answer. Make sure that you are keeping track of the ordering and that you list the arcs in the order that they were added along with the total, because that's the only way really that someone can tell for sure that you actually used Prim's algorithm. And there you go, that's what you're working should look like in the end. So let's have a think about what the common errors might be when using this method, prims on a table. Um, Obviously things like if it tells you to start a specific node, you must do that. It's likely in exams that will happen because it actually makes it much easier to mark. Um, Forgetting to delete a row, because if you forget to delete a row, then obviously you're in danger of accidentally creating a cycle. And of course, it's a lot harder when you've got a table to notice if you've done that. If you're doing it pictorially, then you might spot a cycle, but it's harder to do that on a graph, so you need to be more careful. Um, Again, it's easy to forget to look down all the available rows. It's not just the one that you've just been dealing with. Any row that's already from a node that's already been added is one that you need to look down. And of course, forgetting to record the order as you go along, or after you've done it. Either way, it needs to be recorded. Maybe not showing enough working. Again, as I mentioned, it's important that it's clear that you've used Prim's algorithm and not just got to the correct answer using some other method. And of course, it's almost always the case that they will ask you for the total weight once you're done, so make sure you don't forget that, because that's an easy mark to drop. So that concludes video 2.2. The next video will be 2.3, minimum spanning trees, using a new algorithm called Kruskal's algorithm.